This video is going to show you how you can do a confidence interval and a hypothesis test in R. So let's look at problem 914, where we have a bakery. We've just produced a bunch of loaves of bread. The problem says find a 95% confidence interval for the mean weight of all loaves produced today. In chapter 10, when we get to hypothesis tests, it's going to give us kind of an additional question, which is, does that mean weight differ from 1? All right, so let's go bring this into R. What I'll do is I'm just going to copy it over. So highlight the data you want, hit Command C. Notice I did not include the period. And then I'm going to call it x. Okay, so x is equal to a vector, which consists of all those values. And we can get various statistics on this, like if we want to know the length, there's 12 objects in it. And if you do a summary, you can get a 5-number summary plus the mean. All right, how do we get a confidence interval? Well, the first thing to note is that we have a pretty small data set. There's only 12 observations here, and therefore we need to be very attentive to the assumption that the data is sampled from a normal distribution. If we had a very large sample, we could point to the central limit theorem, and normality of the underlying population is not as important. But since there's only 12 observations, we need to be careful about that. So let's go look at a histogram of it. It looks not exactly normal, but it is only 12 observations. This bar bothers me a bit. If I were to look at a box plot, so let's do that, you're going to see the box plot doesn't look too bad. What I'm really worried about here is whether there's extreme skewness and outliers, and we don't have that. So let's go with the assumption that we have at least approximately normal data as a population distribution. Therefore, we're allowed to compute a confidence interval using a t-distribution. So how do you do that? Well, there's a function t-test. Now, before I do this, let's just go look at the help page for t-test. And what you're going to see is that you have to give it some data. That's x. There's a confidence level argument. So I think we were asked for 95%. That's the default. Another argument that I want to point out is the mu equal argument, which is going to be necessary for doing hypothesis tests. So this sets the reference value, the value that's in both the null and alternative hypothesis. And you also have some control over whether you're doing a one-sided or two-sided test. So let's go type this in, t.test x, and I'm going to say mu equal to 1. So remember, we had a reference value of 1, and this will do both a hypothesis test and a confidence interval for us in one go. So first off, we get the mean. So here's the mean. Another way to do this, actually this was already reported to us back in summary, is up here, 1.022. This rounds to 1.02, then 2. So that's the mean. We have our 95% confidence interval right here. We also have a hypothesis test. So if we want to test the null hypothesis that the mean is 1 against the alternative that it's not equal to 1, we get a p-value up here. So this p-value is greater than 5%, although it's very close, indicating we have borderline evidence. So we can't quite reject the null hypothesis, but we're very close. Can't reject the null hypothesis that the real mean is 1. That, by the way, is reflected in the fact that 1 is contained in this confidence interval. So for that reason, we think the machine is probably putting the right amount of bread in each bag. We don't have evidence to say otherwise. I'll just